the price of the goods in another country, right? So if the PPP holds, we know that the Q, the real exchange rate, means how many goods that you could buy, you could exchange for if you use the goods that you buy in a foreign country, right? So the law of the one price will hold if the real relative exchange rate is equal to 1. So that means you could actually reorganize the equation and make it like this. And we say that this is one of the most important equation in macroeconomics, international macroeconomics, because of we link the exchange rate, right, the nominal exchange rate to the price level in two different countries, right? So now the macroeconomic policy in each of the countries would change, would affect the price level, will have the effect on the nominal exchange rate as well. And we know law of the one price and the purchasing power parity, like the macroeconomic counterpart of the law of the one price, purchasing power parity, is a long run concept, right? Because in the long run, we believe that the arbitrage opportunity on the market will be gone. So there will be no arbitrage opportunity on the market. The market will be in equilibrium, so that the parity will hold in the long run. Okay, so basically this is what we discussed on Monday night and in the previous lecture, right? So there's no question. Let me move to the second part of this chapter, which is the monetary model. So now we need to think about, so see if this is the PPP, right? So this is the formula of the PPP. Right, so in order to determine the nominal exchange rate in the long run, we need to know what's the price level in two different countries or two different regions, or like just two different economies using different currencies. Right, so the question right now for us is, how do we determine this, the price level in a country? Right, so we need to construct a monetary market or money market, right? Monetary market, in order to determine the price level, right? So whenever it comes to the market in economics, what do we need to know? We need to know the demand side and the supply side of the market, right? So this is the goal for today. We are trying to construct a model that could show the behavior on the monetary market and how does the price level is determined in each of the country. By doing so, if we could pin down the price level in each of the country, we might be able to pin down a nominal interest rate. So that's the whole story for today. Okay? So then we talk about the function of the money, right? So the function of the money, they have three different major function of the money is the store of the value, unit of the account, and medium of the exchange, right? And then we talk about how to measure the money on the market, right? So you could have the base money, you could have the narrow money, you could have the broad money. So this one is the finest definition of the money, right? So it's just the circulation, the currency circulation, and the private banks reserve. And then if you added some more assets that's less liquid, and you could have the broader definition of the money. Okay, but all in all, the supply of the money it's more straightforward because the supply of the money is the one of the tool that the central bank in each of the country control. So we will usually use M capital M as the money supply. Denote as the money supply. Okay, and then we turn our attention to the demand side of the monetary money. Right, so demand side of the monetary of the money. What is this? We say that in our previous in our first example, the first model that we take a look here, we assume there's a constant. So people has the incentive to hold the money. Incentive to hold the money. And this is because of what? People need to do the transaction. They want to buy or sell the goods on the market, right? So we just assume right now this term as a constant. But the second model we are going to explore today will let this term to be a function of the interest rate. So that means the interest rate will change the incentive to hold the money. And I will explain to you that probably is a better assumption. Okay? And second part of the money demand is the nominal income. So we assume that if people have a higher income, okay, higher nominal income, so if their earning is higher, their demand of the money will be higher. So if you aggregate all the consumer on the market into the country level, if the country's income, so what's country's income? It's the GDP, right? The total gross domestic production or the gross domestic income. Why? It's usually represent the production, right? All the production could be sold on the market, so that becomes the income, right? If the country's production or income is higher, the money demand on the market in that country will be higher. Okay, so this is supposed to be very straightforward. Okay, so by doing so, we know the money supply and we know the money demand. What's the equilibrium condition? The equilibrium condition will be the supply is equal to demand, right? So we just manipulate, just organize all the equations that we have here. This is what we get. So this will be the simple monetary model. Simple money, let's see, what's the textbook called? Demand for money. Simple money market equilibrium. Simple model of money equilibrium. Simple model of money market equilibrium. Right? So once again, who is our goal right now? Are we looking at the money supply, or are we looking at the liquidity constant, or are we looking at the GDP or the total country's income? Some of the symbols are not very clear. Okay, so okay, let me pull up the whiteboard. It's okay, Emily. Thank you for the feedback. Okay, so we have. It's just a review on the Monday night lecture. You know, like we have M, we call it money supply, right? And this one is central bank, right? Central bank's policy tool. Money demand. Right now, in a simple money market model, we define as a liquidity constant, right? Times the nominal income. Okay, what's the nominal means? Nominal means the price level times the total income of the country. Right? If the total income of the country is higher, so why it's higher? the money demand is supposed to be higher, other things be equal, right? In the equilibrium condition on the money market, we know it's supply equal to demand, right? So money supply, it's equal to money demand. Okay, so money supply, we use the notation that's cap M, right? Money demand, it's cap M. So D, that's equal to L bar times PY, right? So once again, what's this? Liquidity constant. This is equal to nominal income, right? So if we get rid of the middle part, this capture the equilibrium of the monetary market, okay? And usually we will represent it, we will prefer it into the real term, right? So how do we convert it into the real term? This is nominal money supply, right? So this is nominal money supply. If we divide it by the price level, so the left-hand side become like this. It's equal to this, right? So the books also tells you that this is the real money supply. Or sometimes it's called what? It's called real money balance. It's equal to a constant, because we are in the simplest model right now, a constant. This one capture the incentives of the peoples holding the money. And Y is the country's total output, all right? So you see here, there's no price involved, right? On the right-hand side, there's no price involved. So on the right-hand side, it's in the real term. And left-hand side, a nominal term divided by price level. This one become a real term as well. Okay, so I think we stop here on Monday. Okay, so go back to my question. My question, I asked you, oh, can I erase it? Okay, thank you. Yeah, thank you, guys. So go back to my question. Since I already know the equilibrium condition of the money market look like this, which one of the variables I'm interested now? Remember, my goal is what? My goal is to find out how do we determine the exchange rate in the long run, right? This is my goal. In order to determine it, I need what? I need PPP, right? Okay, very good, Jacob, thank you. And PPP, what are the exogenous variables in the PPP? So think about that. Using the PPP's formula. If I know the price level in the US, if I know the price level in the Europe, I could determine the nominal exchange rate between those two regions, right? So I'm trying to figure out P-US and P sub Europe, okay, by using the monetary market equilibrium condition, which is here. So as you can imagine, which one supposed to be our variable of interest? That's gonna be P, right? If we pin down the money supply, the liquidity constant, and the total output, can we know P in that region? Okay, one more time. If we pin down money supply, liquidity constant, and total output in one of the country, can we pin down the price level in that country? This is just yes or no. Yes. And simply just apply this formula, right? The monetary equilibrium, equilibrium of the money market formula, right? If I know M, I know P, I know L bar, I know Y. So 4 variables, I know 3 of them, so I could figure out the last one. Right? So this is exactly what we are trying to do right now. Okay? Let me pause a little bit. Is there any question? Okay, remember everything we're trying to do is to pin down the exchange rate change in the long run. That's my goal. Exchange rate is still my topics in the international microeconomics, right? So in order to pin down this, I need to learn the concept of the purchase power parity or the law of the one price firstly, right? So by our discussion, according to our discussion on the Monday night, this is the PPP that we all agree on, right? So now becomes in order to pin down the exchange rate in the long run, I need to know the price level in the US and the price level in the Euro. If I want to know the exchange rate between US dollar and Japanese yen, what do I need to know? I need to know the price level in the US and the price level in Japan. Right? So in order to pin down in order to forecast the exchange rate, predict the long run change of the exchange rate, I need to know the price level of the counterpart on the foreign exchange market. Right? So that's what I'm doing right now. Okay? So if this is the case, okay, so I know this is the monetary market's equilibrium condition, right? So if I'm looking at the US market, M US over P US is equal to L US times 1 US. Right, so this is US monetary market equilibrium condition. Right? So if we use the algebra, doing the algebra a little bit, what's the PUS looks like? It's just the algebra. Okay, so the numerator is MUS over LUS times YUS. Right? So you see the price level in one of the country could determine by 3 variables. Right? Once again, the price level in one of the country could determine by 3 macroeconomic variables here. Who are they? Money supply in the numerator, liquidity constant in denominator, and the total output in denominator. Right? So go back to my original question when we begin this discussion. we try to find out P. We try to find out P in this equation. And I have 4 different variables. I need to know 3 of them so that I could figure out the last one. If I figure out the price level in one of a country, can I figure out the price level in another country, say in Eurozone? I can, right? So if I know the money supply in Euro, not yet. Exchange rate is something we are going to determine.
I thought it was if you have one price and you have the exchange rate, then you can find out the other price.
Well, that's also the question. Yeah, sorry. Yeah, I just figured out that I might confuse you. Yeah. So I just want to let you know. No, my original question is going to be like, if using this method, I could find out the price level in one of the country. Can I use the same method to find out the price level in different region? That's the question. Right. So the answer is yes. Right. So if I know all 3 variables in the Euro, so N monetary supply, money supply in the Euro divided by the constant, liquidity constant in Euro, total output in Euro. If I know those 3 parameters, I could also pin down the price level in Euro as well. Right? So this is exactly what we are going to do here. So let's see. Let me erase all of them. Can I erase now? Thank you. Yeah. I hope I have a large whiteboard here, but kind of a constraint in a small space right now. Okay, so let me just copy the. Will we do an example in question? I think in the lecture slides there's no numerical example, but if you need, I could put one of the example in the homework assignment. What do you think? Okay. Okay, so I'll put it down. Okay, so the homework assignment in the monetary equilibrium condition. Okay, so this is my real money balances, right? That's equal to liquidity constant times the total output of the country. Okay, so use the algebra. P is equal to M divided by L times Y. Right, so in the US, PUS is going to equal to the money supply in the US divided by the constant in the US times the output in the US. Right? And in the Euro, the idea will be the same. Right? Okay, and in the books, it tells you these 2 equations are the example of the, it's on the slides, so you don't have to copy down, fundamental equation of the monetary model of the price level. Price level. Okay. So you see, if we get rid of this term, the constant term, the price level in each of the country is proportion to the money supply in that region over the total output in that region. Right? So if we apply this idea, the exchange rate between two currency based on the PPP is equal to this, right? The first part of the equation is equal to PPP. Right? It's based on PPP. You just switch the variable, right? And then the second part is you using the equilibrium condition in the monetary market in each of the country. So what's PUS? P sub US, that's equal to this term, right? So MUS divided by LUS times YUS over MEU divided by LEU. Right? So the exchange rate between dollar and euro is decided by the parameter such as money supply in the US, the money supply in the Europe, the liquidity constant in the US, liquidity constant in Europe, the total output in the US, total output in the euro. Right? So you see what? This is all in the relative term, right? So here, this is actually the ratio of the price level, right? Or the relative price level. And how do we call this term? If we organize it, MUS over MEU divided by LUS YUS. This is the money demand, right? Relative money demand between those two regions, those two countries. And this is relative money supply between those two regions. Right, so you see the idea of the exchange rate shows up right now. The big picture of the exchange rate shows up once again. Everything is in the relative term. Right, so now the exchange rate between those two currencies actually could represent by the relative supply between those two regions and the relative money demand between those two regions. Is there any question? This is the core of this chapter. Good. Just the algebraic manipulation right now so far, right? So once you know PVP, and you know monetary, and once you know monetary equilibrium condition, then you can figure out this formula. You should be able to figure out this formula, right? Okay. So let's think about one of the case. Okay. So the implication of the fundamental equation of the monetary approach to exchange rate are intuitive. Okay. Right now we think about, let's stare at this equation a little bit. Suppose the U.S. money supply increase, all else being equal, what will happen?
Can you say that again?
Suppose the U.S. money supply increases, all else equal, what happened to the exchange rate?
It would increase.
And it's because
the nominal money supply would increase relative to the other country.
exactly, and the relative money demand remain the same, right? So go back to my question. I hope I have the bigger space. So stare at this equation, exchange rate equal to this, relative money supply divided by relative money demand between the two countries, right? So, okay, let me use another one. Can I erase it? Okay, I guess that's yes. Okay. So what do we have right now? Exchange rate between two currency is equal to relative money supply between two countries divided by relative money demand between two countries. Okay, so my question is, if the money supply in the US increase or else equal, what happened to the exchange rate? So Ryan just said that the exchange rate between dollar and euro will increase because relative supply of the money between US and EU increase, whereas the relative demand of the money between EU and the US remain the same. Right? Mathematically, it's easier to show. Where is your money supply of the US? It's in the numerator, right? The numerator in the numerator. So this term increase, other things holds the same. This term is supposed to increase. So the nominal exchange increase, what does it mean? That's in chapter 12. Definition of the exchange rate. If the nominal exchange rate increase, dollar against euro, what does it mean? That you need to pay more US dollar to exchange 1 unit of the euro, right? So that means the dollar depreciates against the euro. So you see, one country's policy now play a role in determination of the exchange rate. So let's step back a little bit. What is the beginning of our analysis? Money supply in the US increase, right? The Fed using expansionary monetary policy, or there's another more common term, quantitative easing. If everything else, for example, the money supply in the Europe, the output in the US, the output in the Europe, the liquidity in the US, the liquidity in the Europe remain the same, the US dollar is supposed to be depreciate. Okay? Okay, so let's move on to the second example. Okay, instead of the US monetary policy, okay, now suppose the production, the technological improvement just happened in the US. So now the real income level of the US increase. Okay, what will happen?
It would basically just be the opposite of what just happened. The right half of the equation basically means that the money demand increased relative to Europe, so the exchange rate would decrease.
Yes, that's exactly the answer I'm looking for. Right? So if the US increase, so where is the change in the in this equation? YUS is here, right? So now it increase. That means the relative money demand in the US, relative money demand between US and Europe increase, right? Because everything else remain the same. This term increase. The income in the US increase so that the money demand of the US citizen will increase, right? Because people have the incentive to hold the money because of the transaction. Okay? And the money supply in the US, in this case, remain the same. So relative money supply remain the same. Okay, so the denominator increase, numerator remain the same. So the whole value of the exchange rate will decrease, right? So once again, Ryan just tell us the right answer. The value of the exchange rate will decrease, right? And in the plain word, how do we say this? That means what? That means you can use less US dollar to exchange for 1 unit of the euro. So that means the US dollar appreciate. Exactly. Thank you, Jake. Against euro. Right? So this two example, I just want to show you that the macroeconomic variable of the two counterpart of the country will have the effect, will affect the exchange rate, right? And we could find out this by two ideas that we just learned. One is the PPP and one is the monetary equilibrium condition. That's it. Is there any question? Okay, so this is all in the absolute term, right? So remember that. I will save it for tomorrow. What does it mean?
I'll save it for office hours.
Oh, okay, okay, okay. Oh, okay. So all of the ideas we just discussed, this is in the absolute term. Remember, we have one thing called relative PPP, right? So relative PPP means what? Oh no, relative CIP and UIP. We have talked this before. Means the change of the condition in the long run, right? So now we move on to the growth, the change rate of the macroeconomic variable. All right. Should I go back to the slides? Okay, maybe go back to the slides will be better. Also, okay. Okay. Page 30. Okay, so what we just go over, let's use the slides to review it one more time. Okay, so this is called a simple monetary model of the prices. Okay, that means what? We have the monetary supply divided by the price level. It's equal to liquidity constant times the total output in one of the country. Now, if I manipulate it a little bit, P is equal to M divided L times Y. Right? So I could use this formula to find out the price level in different region. And this is called the fundamental equation of the monetary model of the price level. Okay? And then the next step is we use this to connect with the PPP. Right? So this is the PPP. Right? And then we just plug in PUS. This is PEU. So we find out the numerator term is called a relative monetary or money supply. Right? So relative means the ratio between two countries. And then in the denominator is the relative money demand between those two countries. right? So I give you two examples. One is if the US money supply increase. So this means MUS increase, all else being equal, right? So here, MUS increase, this term will increase, denominator will remain the same. So the whole term will increase. The whole exchange rate increase, that means this exchange rate means dollar depreciate against euro, right? So if the US money supply increases, so the common term is called quantitative easing, QE. If US just using the expansionary monetary policy or money supply increases, that means all else being equal, ceteris paribus, that the exchange rate between the US dollar and the euro will increase in its value so that the dollar will depreciate. The second example that I give it to you is that if the real income of the US increase, so what is this variable that we use in the model? This variable is YUS, right? So YUS increase, that means the relative demand of the money in the US will increase, whereas the relative money supply in the US remain the same. Numerator remain the same, denominator increase, the whole term will decrease. So that E is dollar to the euro decrease, that means dollar appreciate against euro, right? Okay. Yeah, go ahead, Jay.
So say income decreases and supply increases, and everything else stays the same.
Okay, so that will be ambiguous, right? Because you change two variables simultaneously,
Okay.
right? So let's see. Yeah, it's a good question though. Let's see in the whiteboard. Or can I
Okay,
use
I don't.
this one? Yeah, maybe I can use this one.
I'm just interested.
Yeah. So okay, get rid of this example. So now if we encounter example number 3, case number 3. Okay, so monetary supply, money supply in the US. Okay. In US increase and real output of the in the US also increase. What will happen to the exchange rate? All else being equal, right? Jacob, this is your question, right?
I said income decrease.
Okay. If income decrease, then we might be able to figure out. Okay, so let's see. So exchange rate, it's equal to this, right? So where are the two variables that change? So the first one is the money supply increase, right? But the money supply in the Europe remain the same. So the numerator, it's increased, okay? And then the denominator, let's see, the numerator in the denominator, it's decreased, whereas the denominator in the denominator remain the same. So the whole value of the denominator decrease. Okay? And if this is the case, the numerator increase, denominator decrease. The whole value of this number will increase more. So in this case, if the money supply in the US increase and the real output in the US decrease, then the US dollar, well, depreciate more,
Against the
right? In compare with the original case. Good question.
Got it. Thank you. I just needed another
Magnitude
example.
will be bigger. Magnitude will be bigger.
What's that? Say that again.
Magnitude, the magnitude of the change will be bigger.
Yes.
The exchange rate depreciate more, right? The exchange rate, the value of the exchange rate increase. That means the dollar depreciate more in compare with the original case. That sounds good?
Yep. Thank you very much. Appreciate
Yeah, it's a good question. So yeah, in the beginning I was a little bit confused by your question. So you can think about that. If those two terms both move in the same direction, say that the money supply in the US increase, real output in the US increase as well. So the effect will be ambiguous. We need to know which one is bigger.
it. Everyone would move, shift upwards. So
Yep. Okay, so we need to move on to the inflation and deflation and the money growth, the relative term of the, or you could say it's the relative term of the PPP and the Fisher effect. Okay, so here we just defined another term. It's called the growth rate of the money supply. Okay, so everything in the change rate, what does it mean? Means the new variable minus old variable divided by the old variable, right? So we use money supply US sub t plus 1 means the t plus 1 at a t plus 1 period of the time, the US money supply. Right, so now I'm looking at two timing. One is t, one is t plus 1. I'm trying to figure out the growth rate of the money supply. So this term is defined by this. Okay? So you actually could reorganize it as MUS t plus 1. It's equal to MUS t. Right? So this is your change rate. Okay? And it's the same thing if we switch our attention to the real income. The growth rate of the real income is defined as the new real income minus original real income divided by original real income. Okay, so using the same idea, if you want to write as this, the new real income is equal to the original level times 1 plus the growth rate. Okay, so just basically this is just the growth rate, definition of the growth rate. New minus original divided by the original. Okay? And then if we using the equilibrium condition in a monetary market, once again, so we have this price level is equal to the money supply divided by the money demand. right? So we want to know what's the change rate of the price level in the US. So the change rate, the growth rate of the price level, the change rate of US. Okay, and we give it a name, the change rate of the price. It's called inflation rate. It's something you should learn in the macroeconomics. And we use pi sub US to denote it. Okay? And once again, here, this is something you have to memorize right now. Or if you want to use the, using logarithm, using derivative, you take the log for on each side and take the derivative with each of the variables. This is what you get. The change of the price level is equal to the change of the money supply minus the change of real income. Right? Originally, they are the ratio, but when it comes to the change rate, this change rate, the change rate in the left-hand side, becomes the differences between the numerator's change rate minus denominator's change rate. And we assume L here is a constant, right? So if we assume this one's constant, that means there is no change rate here. Okay, let me pull up the whiteboard. I have the monetary market equilibrium equation like this, right? Now I want to know, this is in the absolute term. I want to know the growth rate of all the variable. What's the growth rate of the P, and what's its relation with the growth rate of M, growth rate of Y, right? But we assume that the liquidity constant, it's the same. Okay, so the books tells you the change rate, okay, or the growth rate of the price level. It's equal to the change rate of money supply minus the change rate of real income. Use the notation that we just have. So the P, the change rate in the price level has another name that's called inflation. Right, so this is called inflation. So the inflation in the US, it's equal to the change rate of the money supply in the US. So that's something we call mu minus GDP growth rate. Okay, so what I told you before is if you know the logarithm, you could take this, take the log both hand side, take the derivative with respect to t, and then you will get right, you will get MUS. Right, so the variables in the absolute term, in the level term, it's in the ratio, their growth rate will be the differences. That's the idea. Okay, but if you cannot accept this, then just memorize this will be good enough. This means the growth rate of the money supply. And this is the GDP growth rate. Right? And by the same token, it's the same idea. If we apply it to the European market, pi, the inflation rate in the euro, a tie t could be represented as the monetary growth rate of the euro minus the growth rate, real income of the GDP. Well, sorry, in the euro. Okay? Okay, and then if we're using relative PPP, right? So we have relative PPP. So I will have this equation, the change rate of the exchange rate. It's equal to the inflation rate differential. And I already know this one, I could represent as the growth rate in the US money supply minus real GDP growth rate in the US. And the second term will be money supply in the euro market, the growth rate of the money supply in the euro minus growth rate of the European real income. Right, so what is this in the left hand side? Left hand side is the change rate of exchange rate. It's equal to the inflation rate, the differences of the inflation rate between the two countries, right? And by the monetary condition, we know the inflation rate is equal to the differences between their money supply growth rate and the growth rate in the real income. Then, if we just organize a little bit more, we could write the equation like this. What is this term? It's the differences of the money supply growth between the two countries, right? So this is the differential in nominal money supply growth rate. So what is the last term? The last term is the differential in the last term is what? What is GUST? What is GEUT? Yeah, the differential of the output growth rate, right? So you see, everything's in relative term. Right? It doesn't matter what is your absolute growth rate in money supply. It doesn't matter it's your absolute growth rate in the GDP. As well as your money supply is larger than the other people's money supply's growth rate. That means your dollar will that means your exchange rate will depreciate. If your GDP is growing better than the other countries, that means your nominal exchange rate will decrease. So that means your currency will appreciate. Okay? So this is very important. That's on the slides of page 37. Okay, so think about the intuition. If the United States run the looser monetary policy in the long run, measured by a faster money growth rate, the dollar will depreciate more rapidly, right? So if the U.S. runs a looser monetary policy, expansionary monetary policy, means they print a lot of money, right? They buy the securities back on the market, so they give the money, they give the cash into the money market more. So the mu UST increase a lot. If this is the case, the exchange rate will depreciate faster. Whereas if U.S. economy grow, yeah, good. If U.S. economy grow faster than the counterpart of their trade partner, right? Say that Europe, the U.S. Oh, here it's U.S. It's a typo, U.S. The U.S. Oh no, here it's EU. Sorry. Yeah. If the U.S. real GDP grows faster than the Europe GDP growth rate, this negative term will be bigger, so that the change rate of the exchange rate will decrease. So the dollar will appreciate against the euro. So the question I got in the chat room is the reason why the Fed cannot just print more money during the recession. Yes, this is one of the reasons. Great, yeah, good. Okay, so based on this model, we could predict, right? So we could predict our exchange rate. By how? So let's recap a little bit. So now I already have this this formula, and right? And I also know that pi, the inflation rate, is determined by two factors. One is the growth rate of the monetary supply. One is the growth rate of the GDP. Right? So if I know the mu, the monetary supply growth rate in the US, given other things hold equal, can I know what is the change rate in the rate? I hold this is equal, this is equal, this is equal. This increase, this will increase, right? So I know this. I should be able to predict this. Let me go back to the slides. Okay, so how do we forecast the long run exchange rate? Right. How do we forecast the long run exchange rate? Okay, so assume that US and European real income growth rate are identical and equal to 0. Also, the European price level is constant and European inflation is 0. Based on this assumption, examine two cases. So case 1, one-time increase in the money supply. So what happened? If there's 10% increase in the money supply, okay, in the US, okay, the real balance, okay, remain a constant because real income is constant. Remember that? So this is the real money balance. If the real GDP in the US hold the same, this term should remain the same, right? So that means what? That means, okay, so A and B just imply the price level and the money supply N must move in the same proportion. So there's a 10% increase in the price level P as well, right? So the mechanism looks like this: 10% increase in money supply. But in the US, the real income does not change. So that this term are going to be a constant, right? In order to hold this term be a constant, you need 10% increase in the price level as well, right? So in this case, makes sense, yeah. Thank you. In this case, PPP implies that exchange rate E and the price level P must move in the same proportion, right? So now I have this. So E dollar to euro is equal to, right? If the price level in the EU is remain the same, right now price level in the US increase by 10%. PPP tell me I should have exchange rate increase by 10% as well, right? So 10% increase in the exchange rate in the plain world, what does it mean? US dollar are going to depreciate by 10%. Right? So this is one of the case. How do you predict or how do you forecast the exchange rate in the long run? By using by observing the monetary policy in one of the country. So if you see one of the countries suddenly just print out all the money, use a very aggressive expansionary monetary policy on the market. So they collect all the treasury bonds, their national bonds on the market. They buy a lot of the treasury bonds from the market, so they pour a lot of cash into the market. That's not a good thing for the currency. So intuitively, think about what? Suddenly, in the market, a lot of the money just shows up. The value of the money, of course, will drop. Right? So if you go to the foreign exchange market, nobody wants your currency anymore. So your currency will depreciate against the other currency. That's the intuition, right? Whereas on the other hand, if you're using very limited monetary policy, means you didn't print a lot of money, you just collect the money back from the market right now. That means in your domestic market, your currency become less. So people holding your currency become more valuable. So other people, if everything remains the same, other people want your currency relative more so that your currency will appreciate. Yeah, Jake.
Yeah, just a quick question, not really related to this at this moment, but how does the U.S. government, maybe the Fed, well, how does it keep track of how much actually printed?
Well, so we will talk about this one at the end of the chapter, I hope today. So they will pin down the inflation rate so that they could. So like if you pin down the like say this year's target, the Fed are going to let the inflation rate of 2020 become 3%. So inflation rate it's determined by what in our model right now? The inflation rate is determined by the growth rate of the money supply divided minus the growth rate of the GDP. Right? So after calculating the growth rate of the GDP, they're supposed to know what is the corresponding monetary supply growth rate they should do. So they will follow that and then to print the money to exercise the monetary policy. The big picture is like that. So they will pick the macroeconomic variable, either it's the exchange rate or the inflation rate, or it's one more term, inflation and
Depreciation.
yeah. So they could pin down the inflation or the exchange rate so that given the growth rate of the GDP, they should be able to know what is the growth rate of the money supply should be, so that they could according that to decide how much money they have to put into the market this year. That's the idea.
Great, thank you.
Yeah. So the second case the books tell us is what is instead of a sudden increase in the money supply, that the growth rate of the money, right? The growth rate of the money suddenly just increase. So for example here, at time t, the United States raised the rate of the money supply growth to rate mu plus delta mu from a steady fixed rate mu. So originally the growth rate of the money supply is mu. After time t, okay, this is before time t, it's mu. After time t, the growth rate of the money supply becomes mu plus delta mu. So the growth rate of the money supply increase after time t. Okay, so the first two part, the mechanism of the first two part are the same. Money supply is growing at a constant rate. Okay, real money balance M divided by P remain constant as before because Y is the same as we assume. So that implies what? The price level and the money supply must move in the same proportion. So P is always constant multiple of the M. Okay, the reason is because we need to hold this ratio as a constant. Right? But now we know the growth rate of the money supply increase suddenly. So that the inflation, the price level should increase at the same direction and the same magnitude. Okay, so if the P increase as well, E will increase. So that will means my dollar, my currency will depreciate. Let's take a look at the graph. So before time T, okay, money, price, and the exchange rate all growth rate at mu, right? So this is the part before period of the T, right? So this is time, and this is money supply growth rate. Oh, well, no. So the vertical axis will be money supply. So if the growth rate is mu, that means it's a upward linear line, right? After T, somehow the central bank in this country, okay, in the case of the United States will be Fed, right? The Fed decided to use more aggressive monetary policy so that the growth rate of the money supply suddenly just increase. So you see the slope becomes steeper. Okay. However, the real output does not change, right? So based on our assumption, L, Y is the only two factor will affect the money demand. Now Y is non-change, L is a constant, so NP will remain the same. Okay, real money balances remain constant. Okay, so what this implies to the change rate in P, the price level will move at the same direction and same magnitude of the M. Right, so the P originally growth rate are identical to the M's. Now, after the policy shock in M, the growth rate of the money supply moved from mu to mu plus delta mu. The P will change from mu to delta mu plus delta mu as well. And this is based on the assumption that Y, the real income, does not change. Right? So if we know the P move like this, what do you expect the E? Based on the purchasing power parity, E is supposed to move identically to the P. Right? So in this simple model, you see E, the exchange rate, price level, money supply, they are co-integrated. If the money supply increase, growth rate of the money supply increase, right? The inflation rate will increase so that the change rate of the exchange rate will increase. Okay? So this is the simple model that we just explored. Here are the more general model. I will skip the application part. So application part just show you that the money supply growth rate are perfectly correlated with positively correlated with the exchange rate. Okay, so yeah, some of the story you could take a look in the textbook by yourself, but there are more important things here. It's the general model. So the only thing the only thing difference is here. It's what? It's what? It's the L assumption. So remember that in the simple model of the in a simple model of the money market, MS is the supply, right? So MS is equal to M. So supply, money supply. What about demand? Demand is equal to P times L times Y. That is the first model we look at today, right? But now, instead of assume L is a constant, right? I call it liquidity constant. Now, L becomes a function of the interest rate. That is the general model we are looking at right now. Okay, so what is the equilibrium condition? M is equal to P times Li times Y, right? So that's equal to M. P is equal to Li times Y. Okay, previously we only explored the change in Y, monetary supply, right? Because our goal is to find out the change rate of the P, right? Our goal is try to find out what's the change of the P based on the information of the money supply and output. There are one more thing we need to consider right now is the interest rate. An interest rate will change people's incentive to hold the money. Why? Think about that. That's on Monday night. We discussed that the interest rate means it's actually the cost of holding the money, right? Instead of say deposit to the bank, if you hold the money, it means you forgive the interest that the bank are going to pay to you. So if the interest is higher, you supposed to have less demand of the money, right? Because the cost of holding money increase. So the incentive for you to hold the money will decrease. Okay, one more time. If the interest rate that banks are going to pay to you increase, that means the cost of holding the money increase, so that you don't want to hold the money, right? So that the money demand will decrease. That's the idea in this model. That's the only difference. Are you guys still with me? Do we need a break or not?
Yeah, I'm with you. That makes sense. Makes sense.
Make sense?
Well, as much as I can, I suppose. No, I understand.
Yeah, so let's move on to the next slide. So yeah, quickly I will just go through it. Okay. So now the demand of the money. Oh, sorry. Previously, this one is a constant, right? Now instead of being a constant, I let L as a function of Y, and then if I increase, L will decrease. So they will move the opposite direction. Okay, so interest rate increases, uh, uh, the cost. Okay, let me follow a whiteboard. liquidity right now is equal to L times PY, right? What is L? I call it liquidity constant, right? So this could be seen as a parameter for money demand. Okay, so now we assume that this term, okay, so in this general model, we assume this term, L, it's a function of I, so L is a function of interest rate. But we don't know exactly the functional form. We just know that I could determine L. Okay, so if the I, okay, interest rate increase, L will decrease. The mechanism behind it is what? Interest rate increases, right? The cost of holding the money decrease, right? Oh, sorry, the cost of holding the money should increase. Because if you save it to the bank, right? You save it into the bank, you could get more interest rate. You could get more interest, given you put the same amount of the money into the bank, right? So the cost of holding the money increase. The opportunity cost of holding the money increase, so that you prefer not to hold the money. Money demand decrease, right? So that's the idea. So that you see, the interest rate play a role in determining the price level as well. Previously, we said that monetary market equilibrium condition is this, right? And P could be write as M L Y. Previously, we believed that if I know money supply, if I know real output, I can know the price level. But the general model tells you no. One more thing we need to consider, which is the interest rate. Other things are the same. Other things in the general model are exactly identical to the simple model. Okay? So if we okay, so there's a graph in the slides. There's a graph in the slides. I think it's worthwhile to take a look. So, 55. Yeah, so 47, yeah, 55. This one. Yeah. So if this is the demand curve of the demand curve of the real money balances, right? And this is the nominal interest rate, the LI times Y US, supposed to be negative slope curve. Okay, if you think about that, the real output increase. So if y2 is larger than y1, then the demand will shift to the right. Okay, so take a look of the description here. So left-hand side, the panel A shows that the real money demand function for the United States. A downward slope implies the quantity of the real money demand rises as the nominal interest rate $I falls, right? So L, right? So here it should be real money balances. It's this. That's equal to this. Right? So if this one holding the same, the the interest rate falls from this point to this point. The L are increasing. Right, so just like a normal demand curve, right? So normal demand curve, the price and quantity are negative correlated, right? The price will drop, the quantity will increase. This is the same. So this is negative slope. That means the variable at the horizontal axis and the variable in the vertical axis, they are negatively correlated with each other. And this one is just telling you if exogenous variable like the Y, the real output in the country increase, that will shift the demand to the right. Okay? So in the future, we will have a curve that's the supply looks like this. And you will see how do we determine the interest rate in the future. Okay? But very quickly, this one just want to show you right now, how do we derive out the Fisher equation, the Fisher effect? Okay, so now real money supply equal to this, real money demand equal to this, and we know I and L, they are negatively correlated. So with two old friends that we have, right? So this one is PVP, right? It's relative PVP. We know the change rate, the expected rate of the dollar depreciation or the change rate of the dollar is equal to the differential of the price change, which is the differential of the inflation rate between two countries, right? And also by the UIP, we know that approximation of the UIP, we know that the expected rate of the dollar depreciation, it's equal to the differential between the interest rate in domestic market and the interest rate in the foreign market. So you see, if we combine those two, if we combine this and this, what will we get? We will get the expected inflation rate between two countries supposed to equal to interest rate differences. And this is somewhat very striking. The relative inflation rates are equal to the differential of the inflation rate are equal to the differential of the interest rate. Okay, and this is a well-known Fisher effect. So what Fisher effect predict? The Fisher effect predict that the change in the opportunity cost of the money, where's the opportunity cost of the money? Opportunity cost of holding the money is these two terms, right? This is the opportunity cost of holding the dollars. This is the opportunity cost for holding the euro, right? is equal not just to the change in the nominal interest rate, but also to the change in the inflation rate. Okay, so if we rearrange the equation, I think this is the biggest invention of the Fisher Fisher equation. So what is this term? I minus inflation rate in the US. This we call the real interest rate. So the nominal interest rate you see in the banks, it's not a real interest rate. If you put your money in a bank and the price level goes up, the real interest rate is equal to the interest rate minus inflation rate. Okay, so this idea is important. So what does it mean? It means the nominal it does not matter anymore. All we need to focus on is the real interest rate. And how do we calculate the real interest rate? The real interest rate is by subtracting the inflation rate to the nominal interest rate. Okay, so inflation, the price level, plays a very important role here. States the results state the following: if PPP and UIP hold, the expected real interest rates are equalized across the country. Okay, this is called a real interest parity, right? So now, how many interest parity you have right now? You have uncovered, you have covered, and you have real interest parity. Those three. Okay, and what is the meaning of the real interest parity? Implies arbitrage in goods and financial market alone is sufficient in the long run. The equalization of the real interest rate across the countries. So no matter which market you are looking at right now, you arbitrage in the good market or you arbitrage in the financial market, that will lead you to the same result, right? So the only thing that matters is the real interest rate. And how do we calculate real interest rate? Is the nominal interest rate minus the inflation rate. Okay. Real interest parity. So take a look at the real interest parity very quick. In the long run, all countries will share a common expected real interest rate. In the long run, expected world interest rate denoted as R star. So this will be the equilibrium. In the long run, means what? Every country, the differences between the nominal interest rate and the expected inflation rate are supposed to be the same with each other. Okay, and we treat R star as an exogenous variable, something outside the control of policymaker in any particular country. So this one is not controlled by the domestic government. The Fisher effect is even clearer because by definition, the interest rate of the dollar is equal to the world real interest rate plus the inflation rate in the US. Right? Or you just organize again. right? So not only interest rate is important, but also the price level is important. And those two represent two important markets in a macroeconomic world. This is the equilibrium price of the financial market. This is the equilibrium price level of the goods market. Okay, and how does it relate it to the exchange rate? So let's see. Everything's the same, right? So what is this part? How does this equality hold? Anybody? Anybody? How does first equality hold? I just need 3 words. It's PPP, right? The nominal exchange rate between two currencies is equal to the price, the ratio of the price level in two different countries. Right? So this one, it's according to PPP, purchasing power parity. What about the second equality? We use the general model of the money market in both US and Europe. Right? So PUS could be represented by MUS divided by I dollar YUS. Right? A little bit of a refreshment of the notation. What's MUS? Money supply in the US. What's I dollar? Interest rate in the US. What's YUS? Real output of the US. Right? So by the same token, in the Eurozone, this is the same thing. I want to know the price level in the Euro, money supply in Eurozone, interest rate of the Euro, real output of the Eurozone. Okay, so if you reorganize it, you will get a similar idea that we see in the simple model. Right, so this term is the relative money supply between two countries. And the denominator term, once again, is the relative money demand. Okay, so once again, we need to take a look of what happened if the growth rate of the money supply suddenly move from mu to mu plus delta mu. So say now the government in the US suddenly increased the growth rate of the money supply from mu to mu plus delta mu. What happened? So remember the first graph. The first graph is always starting from the money supply, right? So originally the supply is like this. This is time. The horizontal is time. Vertical axis is just the money supply, right? So it's a linear upward line. It's an upward line. So it's a linear. That means the growth rate is a constant, right? But now after time t, the government suddenly increased their growth rate of the money supply. So you see, so delta mu, if delta mu is larger than 0, means the slope will be steeper. The slope will be bigger. The line will be steeper, right? This is the same. But the second graph, it's the differences come into play, right? Remember, what do we have in the previous graph, in the previous model? previous model, the green line MP, the line of MP should look like this. It's a straight line, right? And that's because we believe that L, Y, if Y remain constant, MP should remain constant. Right? However, right now, MP actually decrease. Right? So the second step is causing the inflation and the interest rate to rise. So if the interest rate rise, if I increase, what happened to L of I? L of Y will decrease, right? The change of the interest rate is mu I. The delta I, the change of the delta I is delta mu. So interest rate increase. Interest rate increase. In our new model, in the general model, Li will decrease if the I increase. Right? So real balance will drop. Okay, so this is the main differences here. It no longer to be a flat line as we did before. So what do we predict of the price level? The most important price level. Originally, the growth rate is like the money supply growth rate, right? And then after T, the growth rate of the inflation rate of the price, the inflation rate, the growth rate of the price will be the same with this number, right? So the growth rate of the money, growth rate of the money supply supposed to equal to the inflation rate. But there will be a jump here simply because right now we assume L is a function of I. Okay? Because this one drop, this one cause this one drop. It's because I increase. So that the price level will drop. So what will the exchange rate looks like? The exchange rate will looks like the same with the domestic price level. Right? So you will have a jump here as well. The exchange rate follows a similar path to the domestic price level as shown in penalty. Okay? Okay, the last part, just telling you like the government's policy, they have actually 3 different ways to pin down the policy. They can use the different macroeconomic variables as a target. So this is we call the nominal anchors. Okay, and the combination of those policy we call the monetary regime. So some people are more flexible in the inflation rate. Some people are more flexible on the exchange rate. Okay, so all it depends on what is the goal of the government's policy. So the three nominal anchor choices that emerge are in exchange rate target. So the government will, just try to let the exchange rate not fluctuate more, just in a exchange rate within the bound. Or you could control the money supply target, or you can use the inflation target plus interest rate policy. Let's take a look at the first one, the exchange rate target. So if you try to pin down the exchange rate target, this is your anchor variable. So you need to adjust your local inflation, your change rate of the price level in the home country, your local price level change. By using the foreign inflation rate. So relative PPP says that the home inflation rate equals the rate of depreciation, right? So this is the rate of the depreciation plus foreign inflation. So if you try to use this as your anchor variable, you just set this as a constant, right? So this is your target. You set this as a constant, so you adjust your local inflation rate if you observe the foreign inflation rate. This is the first policy. The first one, anchor variable. And the government have a multiple choice. They could target at the money supply growth as well. So this is basically the monetary policy target, right? So you could control how much money you want to print or how much bonds you want to sell on the market, so that how much money growth in the market you could control it. So if you pin down this, what are the variables that you need to look at? You need to control the inflation rate domestically, observing the output growth. Right, so this is based on which condition? This is based on the money market equilibrium, right, in the relative term. The growth rate of the price is equal to the money supply growth rate minus the growth rate, the real output. Okay, so inflation means the change rate or the growth rate of the price, right? And this is equal to the money supply growth rate, and this is the real GDP growth rate. Right, so if you pin down this, say that you said this is 2% a year, and then you figure out your inflation rate, it's equal to 1%. So how much is the real output growth rate you have to achieve? At least 1%. Right? Otherwise, you cannot reach the goal that you set. Okay? And last but not least, the inflation target plus interest rate policy. So now the anchor variable becomes the nominal interest rate. Some of the European countries like to use this. Okay, and the Fisher effect tells us what? the whole inflation rate is the whole nominal interest rate. So this basically follows the Fisher effect, Fisher equation, right? The inflation rate is equal to the nominal interest rate minus the real interest rate. Or the real interest rate is equal to the nominal minus the expected inflation rate. Okay, so if the later is the constant, if this is the constant, and the average nominal interest rate is stable, inflation can be stable. But the target nominal rate must be adjusted if the world real interest rate changes, as seemed to be the case recently. So this is always the problem because it's hard to calculate a real interest or world real interest rate. Okay, but this one, the nominal anchoring framework, it's quite common in the European country, as I know, because they try to pin down the expected inflation rate. They don't want to have any hyperinflation things happen. Simply just because European in the history of the Europe, the some of the country and some of the war were caused by the superinflation or hyperinflation. So they are quite conservative in the inflation rate. Okay. So with that being said, we finished chapter 14. We finished chapter 14. So, is there any question?
I'll talk
Yes,
to you
go
tomorrow.
ahead.
I'll talk to you at office hours tomorrow.
Okay, yeah, no problem, yeah.
It's late and
I know it's a little bit overwhelming right now, but I try to touch a little bit of the chapter 15. You know, because we are trying to get into the new Keynesian model, so all we do here is try to construct the monetary market. So the Keynesian model, some people might already know. The new Keynesian model is the ISLM model, right? So Mondale-Fleming model. So two of the important part in that model we need to specify, right? So monetary market, it's the first one, and the second one, it's the goods market. So all we do here in chapter 13, 14, and 15 are trying to construct the idea here. So CIP, UIP, and PVP are focused on this. And good market will be covered at chapter 16. And some of the ideas are already been taught in the macroeconomics principle course. So that in chapter 18, we could use the model to analyze the policy. That's the goal. But I don't know if I could finish this or not. Let's take a look at the chapter 15 very quickly. Okay, just briefly give you some of the idea. Okay, so the question to consider here, okay, in the short run, how do the expectations and the exchange rate arbitrage determine the exchange rate? All right, so you remember that in chapter 14, all we consider is in the long run, right? In PPP, in PPP law of the one price, monetary condition, monetary market, equilibrium condition, all we are taking the respective in the long run. Okay, and secondly, we want to know how the central bank's policy choice determine the interest rate, right? We only cover the money demand in the market. What about the money supply? We didn't touch too much in the chapter 14, right? So that's the goal in this chapter. Okay, and then we compare the floating and fixed exchange rate regime. Hopefully we can cover this one too. Okay, so in the short run, in the long run, we call it the monetary approach to exchange rate. In the long run. Whereas in the short run, we call it the asset approach to exchange rate. And it's based on the idea of currency's store of the value function. Okay, take a look at the big picture of the model. This is what we learned before, right? They uncovered the interest parity. Okay, it's the fundamental equation of the asset approach of the exchange rate. Here's a typo. This one's supposed to be euro. So make sure you correct this one. Okay, so this one's supposed to be right. The dollar that you deposit in a domestic bank, it's equal to if you switch your currency to the other country, right? UIP is equal to what? UIP is equal to 1 plus I is equal to this is UIP, right? So remember, using a simple algebra, simple algebra times this is what you get, right? And this term it's equal to this. And if you just expand it out, everything, you will find 1 plus times I. So approximation tell us what? Approximation tells us what this number is small, this number is small. Those two cancel out. 1 and 1 cancel out. This is what we learned before, right? The differential of the interest rate between the two countries are going to be equal to the change rate of the exchange rate. So if you're using the home country is the US, the foreign country is the euro, this term is called expected depreciation rate of the dollar. Expected rate of the depreciation of the dollar. And this is the US deposit interest rate. And this is the deposit rate in the euro. Linear approximation of the UIP. Okay. So if we step back and take a look of the big picture of the model. So what do we have right now? What are the known variables we have right now? We are trying to using the nominal interest rate in the home country and a foreign interest rate, right? Nominal interest rate in a foreign country, and the expected future interest rate to figure out the exchange rate. Right? Remember in the chapter 14, in the long run monetary approach, what is the idea? What is the input variable and output variable? The output variable is still the same one, right? We always want to know what's the exchange rate. But in chapter 14, what are the parameters? The parameters are the price level in the US and the price level in the Euro. Right? And in order to determine the price level in the US and in the Euro, we need to know the money supply in the US and the output in the US and the liquidity constant in the US. Right? And here in the Euro, it's the same thing. That's the parameters we need to know. Okay? The goal of these two chapters are figuring out the exchange rate, but they took the different perspective. Okay. Okay, so it's 8:30 right now, so I think it's a good timing for us to take a pause, unless you have any question. Yeah, so yeah, that's call it a day right now. Yeah, I know it's a little bit overwhelming, but I'm doing my best to explain the chapter 14, the long chapter 14 to you guys. I hope you I hope you understand a little bit, and we will come back on next Monday on the chapter 15. So we only have 2 lectures left. Okay, so we only have 2 lectures left. Here's what I'm planning to do. So I probably will only use 1 lecture to finish chapter 15. And then on Wednesday night, the next Wednesday night, I will go over the good market equilibrium condition very quickly, but I will touch the ISLM model, like just very basic idea. Okay, at least to let you know what is the expansionary fiscal policy, what's the expansionary monetary policy, and what is the result on the exchange rate, what is the result on the interest rate and the output and all kinds of macroeconomic variables in that model, because I feel that that's very important. If people ask you about like Mondale-Fleming model, and you need to know after you've taken this course. Okay, so I hope I didn't overwhelm you. So thanks for your participation today, and thanks for all the feedback during the classes. And I will hold my regular hour, regular office hour, as well at 4 to 6 tomorrow on WebEx. So you are you are very welcome, more than welcome. Feel free to join if you have any question. Some people send me the email about your on your homework feedback. I'm doing right now. Some of them I haven't had the time to reply all of the emails. So thank you for your patience in advance, but I will try to do it as soon as possible. All right. So I will post the additional question as well. So the 2 more questions will be on this chapter. Okay, and then additional practice question will be posted, and as well with the also with the answer key. Okay, if that being said, thank you so much and have a good night.
Good night. Thank you.
Thank you.